Today, we will be doing a rainbow density lab. But first, what is density? Let's find out.
Density is how tightly packed the matter is inside an object. Dense objects have more mass per volume than less dense objects. That means there is more matter packed into a smaller space. Think of the golf ball and the tennis ball. A tennis ball is larger than a golf ball, but if you were to hold them both at the same time, it actually feels lighter. A golf ball is more dense than a tennis ball. It has more stuff packed inside it. A tennis ball is hollow inside. It is full of air, which makes it less dense.
First things first. Our materials. For this experiment, we will need sugar or table salt, water, a spoon for mixing, spoons for measuring. In this demonstration, we used a half teaspoon and 1 tablespoon, a funnel or syringe, a straw, tape, glitter, decorating supplies like ribbons and stickers, small cups to mix your colorful sugar water solutions in, vessels of any size or shape that you want for your final rainbow, food coloring, paper, a tablecloth or some other sorts of coverings to avoid creating a mess, and paper towels for cleanup.
Now for the setup. Make sure to lay a covering on your workspace to avoid creating a mess. Put an equal amount of water in each of your mixing cups. In this demo, we use 6 cups with 2 tablespoons water in each. Make sure each cup is a different color. We did red, orange, yellow, green, blue, and purple.
Here I am putting food coloring into water to get my different colored solutions.
Listed here is a detailed step-by-step procedure for this experiment. In short, we want to create 6 solutions with varying densities by mixing dye and adding an increasing amount of sugar or salt in each container. For example, the red solution will stay the same, while the orange solution will get half a teaspoon of sugar, the yellow solution 1 teaspoon of sugar, and so on. Then we will layer our solution and see a rainbow come to life. Now I am putting in my sugar and gently shaking the container so that all the sugar dissolves.
You can also add glitter to your solutions for a fun little twist. Time to pour it in! Now watch as I carefully put in the different solutions into our test tube with the syringe. Make sure that we start with the largest density on the bottom so that all our colors stack properly. We need to make sure that we carefully dip the solutions using our syringe to get the best gradient possible.
Now we know this is looking a little dark. Where's our rainbow? Here's the cool part. Now we need to very, very carefully move our beaker to a source of light. See that? That's pretty cool. The light makes the colors more vibrant. Now, with your new knowledge on density, let's have a discussion. Why do you think the colors separated into layers instead of mixing together?
Exactly! In our experiment, the more sugar in each glass of water, the density of the solution increased. Increasing the amount of sugar in the solution, but keeping the water constant created solutions with increasing densities. The more sugar you mix into the same amount of water, the higher the density of the mixture. So, density explains why the colored sugar solutions stack on top of each other inside the vessel. But then, why can you see the rainbow better under the light?
Those are some good hypotheses. This relates to the Tyndall effect, which is the phenomenon of scattering of a beam of light when passed through a cloudy solution. In our clear solution, the light was able to clearly shine through and display the colors better. Can you think of an example of when you can observe density in the real world?
That's right. Oil in our ocean is a great example. Since oil has a lower density than water, it floats on top. Icebergs are also a great example because ice is also less dense than water, helping it float on the water. Finally, eggs are a really cool example too. The density of rotten eggs is actually less than the water, but the density of fresh eggs is heavier, which is why rotten eggs float on the water and fresh eggs actually sink.
Now you try. This is a two-person job, so make sure to team up with someone and start mixing. You will be getting your own jar that you can decorate to try the experiment here, and another smaller jar to take home. Here, in this clip, is a 7th grader decorating her jar. The next clip includes a 5th grader doing a portion of the experiment to take a sample home. Good luck, Scientistas, you got this.
Scan the QR code to access some handouts. These handouts cover the experiment we did today, provides you more information on why a rotten egg floats and a fresh egg sinks, and includes a fun experiment about density you can do if you want.
But first, let's make sure to clean up.
Can't wait to see you next week, Scientistas, with another fun experiment. Make sure to reach out to us anytime if you have any questions.